If we try to believe.
Hello everyone and welcome back to The Boring Teacher. In the previous video, we were talking about the universal law of gravitation that is given by the Newton. Let us have a small recap of that law. The law says that every object, every particle in the universe attracts every other particle, right? The force of attraction between them is directly proportional to the product of their masses, and the force between them is inversely proportional to the square of the distance between their centers. Okay, and if I write the mathematical form of that force, it looks like this: F is equal to capital G m1 multiplied by m2 divided by d square, where G is the gravitational constant, the value of which is 6.67 multiplied by 10 raised to minus 11 Newton meter square per kg square. This is what we discussed in the previous session. Now, we ended the session with a question that came to my mind, right? The question was something like this: if in the universe each and every object is attracting every other object, then that means that I will be attracting the moon and moon will be attracting me towards each other. Then why don't I move towards the moon, or why doesn't the moon comes towards me? Right, this was the question that came to my mind after learning the Newton's universal law of gravitation, right? Okay, so I'm going to give you a mathematical proof that why this kind of situation is not taking place. Okay, so for that we have to solve the equation. The equation looks like this: F is equal to G m1 multiplied by m2 divided by d square. Now let us specify the terms that are used in the formula. G is the gravitational constant. We know the value: 6.67 multiplied by 10 raised to minus 11 Newton meter square per kg squared. Let m1 be the mass of body on earth. In this case I'm talking about me, so I'm going to write the mass of this body on earth. That means the mass of my body. Okay, and m2 will be the mass of moon in this case, and d it will be the distance between the moon and me. Or if we talk ultimately, it is the distance between moon and the earth, because I'm standing on the earth, right? So the distance between the moon and the earth. Now for this, a few values I have to Google. Say for example, mass of the moon I have to see, and the distance between the moon and the earth, because I don't remember. Yeah. Okay, so here are the values that we are going to use. m1 is the mass of the body, m2 is the mass of the moon, that is 7.35 into 10 raised to 22 kilograms, and the distance between moon and earth is 384,400 into 10 raised to 3 meters. Now let us place all these values in the formula and let us see what do we get. Right, so the force equals to G. The value of G is 6.67 multiplied by 10 raised to minus 11 multiplied by m1 is 8 multiplied by m2 is 7.35 multiplied by 10 raised to 22 divided by d squared, that will be 384,400 multiplied by 10 raised to 3 and squared. Now let us solve this. 392.196 multiplied by, now 10 raised to minus 11 and 10 raised to 22 will give me 10 raised to 11. So 10 raised to 11 divided by, okay, now on squaring 384,400, I get 14776 336 6 0 0 0 0 multiplied by 10 raised to 3 squared will be 10 raised to 6. What do I get is 2.65 already multiplied by 10 raised to minus 9, and on solving these 10 raised to 11 and 10 raised to 6 divided by 10 raised to 6, I get 10 raised to 5. So on solving further, 2.65 multiplied by 10 raised to minus 4, and that will be 0.12365 Newton. So this is the force between an object, that is me, and the moon. We are attracting each other. The moon is attracting me and I am attracting the moon, but as you can see, the magnitude of the force is nearly zero. It is near about zero. That is why the moon does not come towards me, or it doesn't move towards the moon. This is the reason. This was a huge example, taking huge values and calculations it involved. You can take a simple example of two objects kept at a distance of 1 meter. You can take a simple example. Let us say that we have an object A and an object B. Let us take the object of mass A as 5 kilogram and the object of mass B as 10 kilogram. For the sake of simplicity, let us take these kind of values, and the distance between their centers, let us assume that it is equal to only 1 meter. Say for example, the distance between the two objects having mass 5 kilogram and 10 kilogram is only 1 meter. Now what will be the force in this case, right? So F is equal to, let us solve this equation. Let us not talk about the celestial bodies and the object on the earth. Let us solve this. Let us find the value of force. F is equal to G, that is 6.67 multiplied by 10 raised to minus 11. M1 is 5, M2 is 10 divided by D squared, that is 1 squared. Okay, 1 squared is 1, so no need to write it. So we would get 6.67 multiplied by 10 raised to minus 11 multiplied by 50, 3.5 multiplied by 10 raised to minus 11. Now in the terms of decimals, if I expand this, if I'll just write it in the form of decimals, what will I get? It will look like this: 0.1 2 3 4 5 6 7 8 9 10 11. See, this is the magnitude of the force that is acting between any two objects of masses 5 kilogram and 10 kilogram kept at a distance of 1 meter. So you see, as this object, the force acting between these objects is really very small, or it is very minute. That is why the objects kept near each other are not attracted. Actually what happens is, the force is directly proportional to the product of their masses. So as the mass of the object increases, the force also increases. As well as, if you see, it is inversely proportional to the square of the distance. So if the distance will increase, the force will decrease, because they are inversely proportional. It is simple logical thing, right? If the distance between the two objects increases, that means the force will reduce, and if the distance decreases, then the force will increase, right? Now if you talk about the celestial bodies, then the masses of those objects is really huge. That is why the force is also huge. So this is it about the universal law of gravitation and why we are not attracted towards the every other object kept around us, because the value of the force is very minute. So thank you for watching.